Welcome back to Unmolding Science. For centuries, humanity has gazed upon the stars with a mix of awe and frustration. The universe is a vast ocean of darkness, its cosmic islands separated by unimaginable gulfs of empty space. We've always dreamed of traversing these distances, but our fastest ships are laughably slow on a cosmic scale. What if the universe already built the ultimate express lanes for us, disguised as the most terrifying objects in space? What if black holes, those cosmic dead ends, are actually bustling intergalactic subway stations? Today, we're going to tackle one of the most mind-bending ideas in all of physics, the theoretical possibility that black holes could be cosmic shortcuts, or wormholes. This isn't science fiction. It's a deep dive into the mind-bending possibilities of black holes as true portal gateways, exploring a claim that is mathematically sound, even if we haven't seen it in reality. This is a journey that will force us to completely redefine our understanding of space travel and perhaps even reality itself. Let's start by unmolding what we currently know about black holes. The story of a black hole begins with the death of a truly massive star, one at least 20 times the mass of our sun. When these stellar behemoths exhaust their nuclear fuel, the outward pressure that has been holding them up against the crushing force of gravity vanishes. The star undergoes a cataclysmic collapse, shrinking down into an infinitely dense point called a singularity. This singularity creates an immense gravitational pull, so strong that nothing, not even light, can escape once it crosses a boundary known as the event horizon. Think of the event horizon like the edge of a cosmic waterfall. Once you go over, the current is so strong there is no possible way to get back up. This is the accepted, peer-reviewed science we've had for decades, based on Albert Einstein's groundbreaking 1915 theory of general relativity. Our observational evidence, from the accretion disks of supermassive black holes at the centers of galaxies to the ripples in spacetime, detected by LIGO from black hole mergers, consistently supports this one-way destructive nature. For all intents and purposes, black holes are the universe's ultimate cosmic traps. But what if everything we thought we knew about them was fundamentally incomplete? What if that cosmic trapdoor leads not to oblivion, but to somewhere else entirely? This is where things get truly fascinating. The very same equations from Einstein's theory that predict the existence of black holes also contain a bizarre solution known as an Einstein-Rosen bridge, or more commonly, a wormhole. This isn't just a fantasy. It's a theoretical tunnel through the fabric of space-time that could connect two distant points, effectively creating a shortcut across the cosmos. This concept was first explored by Einstein and his colleague Nathan Rosen in 1935, but their initial findings suggested that these bridges would be unstable and collapse the instant anything tried to pass through. For decades, the idea remained a mathematical curiosity. However, in the late 1980s, a Nobel Prize-winning physicist named Dr. Kip Thorne and his colleagues reignited interest. They were the first to demonstrate that a traversable wormhole was mathematically possible. They showed that if you could find a way to prop the wormhole open, you could theoretically travel through it. But this leads to the colossal catch, a hurdle that has so far confined the concept to pure theory. To keep the wormhole open, it would require a special type of substance with negative energy. We call this exotic matter. Exotic matter is a substance with a negative mass or pressure. To put it in a more relatable way, imagine a substance that exerts a repulsive force of gravity, an anti-gravity that would push the sides of the wormhole apart and hold it stable. While we have yet to observe any substance with these properties on a large scale, the laws of quantum mechanics suggest that exotic matter might exist in fleeting microscopic quantities. For example, the Casimir effect, which involves two uncharged metal plates in a vacuum, produces a tiny region of negative energy density between the plates. So, while the evidence is scarce, the possibility of exotic matter is not entirely ruled out by physics. It's the what if that allows us to venture into the next phase of this thought experiment. What if we found a way to create or harness this exotic matter? What if we could finally build these gateways? Imagine a vast cosmic subway system where black holes are the stations. A journey that would take light thousands of years to complete could be finished in a matter of moments. This network could connect distant galaxies and star systems, allowing us to travel from our Milky Way to Andromeda in the blink of an eye. Think about the implications. We could explore alien worlds, harvest resources from distant star systems, and even encounter other civilizations. But it wouldn't be easy. The journey through a wormhole would be incredibly dangerous, a trip that could subject a ship to immense gravitational shear forces, or the slightest instability could cause the portal to collapse while you're inside. And then there's the navigation problem. How would we know where the wormhole's exit is? What if it leads to a region of hostile space, like the heart of a supernova? The challenges are monumental, but the very thought of these pathways reshapes our understanding of reality. This isn't just about faster travel. It's about the very fabric of space-time itself. Imagine space-time as a flat sheet. The immense gravity of a black hole doesn't just pull things in. It warps that sheet, folding it over on itself. A wormhole would be the ultimate fold, creating a direct path between two points that were once separated by an enormous distance. This challenges the very idea of distance and time. Could we bypass the cosmic speed limit, the speed of light, by simply going around it? The existence of these portals would also raise profound philosophical and existential questions. Would we be the first to navigate these cosmic doorways? What if other civilizations have already mastered this technology? Would we be the travelers or the visited? The potential for discovery, both technological and societal, is literally infinite. We're talking about a future where humanity isn't confined to a single planet or even a single galaxy. We're talking about a future where we could be true cosmic citizens. While the idea of a traversable wormhole remains purely theoretical, it's a powerful example of how science isn't just about what we know, it's about what we're daring to imagine. The very fact that this concept is allowed by the mathematics of general relativity means that it's not just a fantasy. It's a tantalizing possibility that encourages us to keep exploring, keep questioning, and keep unmolding our understanding of the universe. What do you think about the idea of cosmic portals? Would you be brave enough to step through a black hole? Let us know in the comments below. And if you learned something new today, give us a thumbs up and subscribe to Unmolding Science for more mind-bending facts. We'll see you next time.